Hello, this is Julian with a object-oriented programming video. Today we are going to cover basic introduction to object-oriented programming, and we want to review the concepts of class, object, method, and attribute. So these are going to be, this is part of the nomenclature, the words that we're going to be using throughout the course, and so we want to start describing what these actually mean and refer to in this concept of object, in this context of object-oriented programming. So this is our basic introduction to object-oriented programming. Now, before we start, I would like to review this. This is the results of the January to May semester. Excuse me, 2017, and this is basically the results of what you told me what you wanted to obtain from this class. And so I think this is a very encouraging result. The two main words, learn programming out of this course, I think it's an encouraging result, and I hope that we can keep the expectations up. So let's dive into this. What is the objective of object-oriented programming? Why do we want to use this paradigm in order to create our programs? So we can divide that into three basic main objectives, one related to the other. The first is to create modular programming, and I think it will become more apparent as we go along how we can build these little modules. And based on this modular programming, we can then give a certain structure to the code which will allow us to simplify the implementation by reusing code and reusing this structure. So if we have this, then we get that, and then we arrive at that. So all of these are like our three-pronged objective. What does it mean to have modular programming? Basically means that we don't want to have a procedural representation. We don't want to have a script in standard where we have, for example, we have our main program and we simply have our code and we run through that sequentially and then we finish. We basically want to have little functions, function 1, or call them methods, function 2, function 3, and depending on what action we're doing, we will execute one or the other. So in this case, we don't have our sequential strip, but we have a series of maybe function 1 and then function 2, and we have a series of events, we have a series of code that trigger the functions to send us either here or here or here. And so this is going to be, these are going to be our modules. With these modules we'll construct a structure, and then that structure will allow us to re-implement code without having to copy and paste and repeat. Now, one of the examples that I use for modular programming, or one of the analogies that I like to use, are Lego bricks. So everybody, I think, knows what Lego bricks are. And if we think of the basic Lego bricks, some of them might be flat, some of them might be taller. All of them have certain functionalities, right? And have very specific characteristics. Maybe we can have a tall, thick brick, or we can have a flat, long brick, or we can maybe have a round brick. And some bricks have specific functionality as well. So each of these are going to be our modules, right? We'll have our basic classes, and they'll have a lot of potential. We can interconnect the modules. They have connectors. They have characteristics, and maybe individually they have limited functionality. They can only do one or two things. What happens when we start? Let's say we take one brick and then we make a whole bunch of copies of that brick, right? We still have the same type of brick, but we have many copies. Well, maybe we can build something that's much more complex. And then if we have many of those copies available, we can build many copies of that more complex structure. And that more complex structure might have more specific functionality or more specific characteristics. And then we can take that more complex structure and build something even more complex, and so on and so forth. So that's the idea of having this modular programming, giving structure to our code and allowing us to reuse this code and structure. So this is something that we will repeat a lot during this term. An object is an instance of a class. So the word class in this case comes from classification, which is something that we do naturally. And the class is going to be our high-level abstraction of whatever object it is that we want to code or that we want to represent. And designing a class then implies taking that abstraction, that classification, and finding out what the information of the object and what the behavior of that object is, so that we can incorporate that information and behavior into a significant entity. And so what does that mean? It means that we have to identify, we have to abstract what these objects are going to be, what these classes are going to be, and we have to identify the characteristics of that object and the functionality of that object so that we can code it into a class. So one example would be an automobile, right? So all automobiles will have similar behavior, or they share a common behavior. So for example, all automobiles accelerate, all of them brake, and we can drive them all. How they achieve that is going to be different, and they'll have different characteristics, but they all have these common behaviors. In addition, there will also be common characteristics. For example, all of them have steering wheels. All of them have some sort of engine or motor, whether it's gas or electric. But in the end, these characteristics are shared as well by all automobiles. So as I'm saying this example of automobile, I'm sure that each of you has visualized an automobile in your head, and none of those automobiles is going to be the same as any of your other classmates' automobiles. So therefore, this concept of automobile is a classification for many things. It's this abstract description of a very complex entity. And so this is what we want to achieve in terms of object-oriented programming. We want to identify these classes and then implement them so that we can create our programs. If we continue with this analogy of the automobile, well, let's take a look then at our concepts of class, of method, of instance or object, and attributes. Okay, so we also have methods over here. So if we have plans or designs or blueprints of a car, that's going to be our class definition. And in this definition, we're basically defining what attributes or characteristics we have, and what methods or functionality we have. So the attributes are the characteristics, and the methods are the functionality or the behavior. But the class definition is simply a blueprint. We still do not have a car. The blueprint may be somewhere on a computer. The blueprint, in terms of this automobile analogy, it might be on a piece of paper or on a roll of paper, but we still do not have a car. And the same in terms of our class definition. Our class definition is going to be the code that describes our class, but we still do not have objects. What are attributes? Well, attributes are characteristics. So for example, let's jump ahead. Attributes are going to be, for example, whether a car can have color, for example, or a car can have a gas tank, or whether the car is going to have scratches on the outside. All of those are going to be attributes. And the methods are going to be a description of how that functionality is implemented. So how the accelerator works or how the brake works. And that's going to be the class method. At this point, though, we still do not have any. Maybe we have the class definition, but we don't have any cars. We don't have any objects. Once we build a car, once you have a car in the parking lot, that is going to be your object. So that is going to be called the instance or the object of a class. And in this case, now we can have, it's a copy, right? We've used our class definition and we've built an object. So if we have a parking lot full of cars, perhaps they're all the same car. We have one single class definition, but we have many, many objects of that class in the parking lot. And now if we get into that car and we want to accelerate or we want to brake, we want to step on the brake, then that's when we execute the method. So even though the method is defined in the class definition, we don't execute it until we call that method from the object. So in order to have the code of a method to have it executed, we have to have an object. So that's one very common mistake in object-oriented programming. We'll write the class definition, we'll write a method, and we'll have the code for all of that method, but we don't create the object and we don't call the method. So people say, well, I've got the method, I have all the code, and it's supposed to do everything is correct, but you're forgetting to create the object and to call the method from that object. And then finally, back to the characteristics we have, which are our attributes. The characteristics can be the color, the tank of gas, or the scratches, or any other individual characteristic. And the values of those characteristics are the class attributes. So again, these attributes are related to the object. Your car might be red with half a tank of gas and maybe a few scratches on your left door. Those are the values of those attributes on your object. So as in a way similar to executing the methods, the attributes usually don't have values until an object is created. So our phrase was, an object is an instance of a class, right? Where our class definition are the plans, methods and attributes are included in those plans, but they're not executed until we have an object from that class. So this idea of designing means that we have to have this abstraction about the information or the characteristics and the behavior of that object. So if we, again, using our car analogy, what are the characteristics that make a car a car? What are the behaviors that make a car a car? So we have to incorporate those systematically into that significant entity. We have to create this abstraction, and this abstraction implies that we're classifying or categorizing. And as you'll see later on, this classification in the design of classes, or this categorization, relies heavily on our capacity as humans to abstract concepts and to have these abstractions and these classifications of our different concepts. So we do have to identify the common elements for each class. Let's say we have a class from automobile, but what about a pickup or a sedan or a sports car? Are those automobiles? Are they in the same class? Do we need new classes? Are those classes related? So for example, can they be a subclass? And we have to think about how those concepts are related between each other, and how those characteristics and behaviors are common to all of these classes or only to a couple of those classes. So for example, a pickup might have an attribute which is a pickup box at the back. Only a pickup has a box, right? A sedan won't and a sports car won't. So maybe that attribute is only specific to pickups, but all of them will have perhaps gas tanks. Well, if it's an electric car, it'll have battery, but all of them will have a driver's seat, for example. So one note, in practice, when we're coding, when we're creating our classes, and we find ourselves duplicating code, so the typical copy-paste, we copy code from one class and we paste it into another, and we're using different classes. This probably means that our classification or our abstraction may not be correct. If you find yourself that you're doing this, that you're duplicating code, maybe it means that we have to review your classification and maybe create a new class, or maybe relate the classes that we have. So, or simply reanalyze your abstraction. So back to our concept, a object is an instance of a class, which we had a couple of slides back. What would be the difference between a class and an object? And along the same tones, what's the difference between a method and an attribute? So the class is going to represent the general abstraction. A class is going to be still the abstract representation, and the object is the individual instance. So remember, the car plans versus the car sitting in the parking lot, or the cars sitting in a parking lot. We can have one single class, but we can have many objects, right? And the difference between method and attribute, both of these are characteristics of our class, but the method refers to the functionality, while the attribute refers to a specific property. If we have a process associated with it, then it's going to be a method, and it's going to refer to the functionality. But if it's simply a value, then that's our property, which will be our attribute. And so this design process implies that we're classifying types of objects, and we're identifying these characteristics in terms of functionality and properties. If we have this idea of abstraction, then we want to take the next step, and we want to encapsulate our implementation. So, for example, we don't really care how an engine or a motor works inside a car, or how a gearbox works, or how the gasoline is transported to the motor, as long as it does what it's supposed to do, right? As long as we are able to get into that car and to sit down and turn the key or press a start button and drive that car, we really don't care what's going on inside. And sometimes it will be a very complex process, sometimes it'll be a simple process. But we might need a lot of additional information. If you're a mechanic, or if you're designing that car, you have to know a lot about the details. But if you're a user of that object, then you really don't want to know, as long as it works, as long as it does what it's supposed to do. And so this is what we refer to as encapsulation. And encapsulation is also referred to as information hiding, because it takes these complex processes and then hides them in the object. So as long as the object does what it's supposed to do, we really don't care what that process is, right? It can be very simple or very complex, but as long as it does what it's supposed to. And the purpose of this is to combine, for example, methods and data in a single class. So maybe we have to process information about our attributes in our class in a method, right? But that is going to be done internally, and we're going to combine that. And we also want to control the accessibility of methods in the data, and therefore the class. We don't want, if we have an object, sometimes we don't want the user modifying that object because it might break it, right? So imagine a car manufacturer. A car manufacturer doesn't really want you to look under the hood or to modify the engine, because you might modify how that object works. And if you modify how that object works, then they'll say, well, it's not my responsibility. So this is basically what we refer to controlling the accessibility. If we have a class, and that class is supposed to work in a certain manner, then we have to guarantee that it works in that certain manner, and we want to limit access to some internal data or some internal methods, and that's also the purpose of encapsulation. Finally, if we have this structure, if we have this abstraction where we've classified our classes and we've encapsulated elements, then we're obliged to have communications between our different objects. So we can have, for example, we might want to share information within a class between different objects, right? If we have a single class and all of those objects have to have information, then how do we get that information to the object? Or we might want to share information between different classes. So we have a car class and we have a road class. How do we communicate between those? Or we might simply want to share information between objects. If we have a car class and a road class, and then if we have a car object and a road object, how do we get those two classes to communicate? If we don't have this communication system, then these concepts of encapsulation and classification really don't make any sense, and they start to break down. So for example, one thing that we don't want to do in terms of coding, we don't want to use global variables, or we don't want to have open attributes or public attributes. We want to keep this encapsulation, but we want to make sure that information is shared between our classes and our objects. How do we implement that? Well, the main manner in which this is achieved is using methods. So we're adding functionality to our class in order to send and receive information between the objects and between the classes. We can implement standard operating system methods as well. But as well, this option is basically a subclass of the first one. Or we can also use static operators to have information shared between objects of the same class. We'll have a special topic for this one as well. So we basically implement our communications using methods adding functionality to our classes. So that's all for this presentation. If you have any questions about this topic, about this presentation, please let me know. Send me an email, come to me in class. Otherwise, we'll see you in class. Have a good one.